Hi, good morning, everyone. So, beta, in today's class, I am going to go ahead and I am going to do another practical session with you. And in this session, we are going to do functional forms using R. So, we know that not always we have to go ahead and write a linear model, right? A lot of times what we need to do is to write a log model or a log model, and each of those model have a separate separate way in which the coefficients are interpreted, right? So the today's session, I am going to go ahead and take question number 2, beta. Please have a look at this question. This is the question that we are going to deal with. So there is this file which says CEOSAL1. I will just talk about this file in a moment. CEOSAL1 basically talks about the salary of CEO. And basically, this is a data file that has been taken from Woolrich, right? So I will just take you through that website also, where Woolrich talks about this file. And we will try to go ahead and interpret this file first. And then we will go ahead and we will try to see different functional forms. So if you look into the question, kya bol rahe bache question? Question number 1 is saying that you have to write a linear regression model. So salary as a function of ROE and sales. Then you have to write a linear log model, right? So salary will be linear and the independent variable will be in the log form. Then you have to write a log linear model, and then you have to write a log model. And while writing these models, what you have to interpret, beta, kya question bol raha hai? So number 1, you need to obtain regression results and you need to get these results in document file. Number 2, you need to go ahead and interpret the regression coefficients. Number 3, you need to interpret R square and adjusted R square or R bar square. So that is going to be our task for the day. We need to go ahead and do these tasks, right, beta? ठीक है बच्चे. Let us go ahead and see this file first. So I am going to take you to the Woolrich website and I will be showing you this file. I hope my screen is visible to you, right? So this is Woolrich website, and यहाँ पे ना जितना भी Woolrich datasets को refer करते हैं in his book, all of those are mentioned here. So in the same book, in the same website, you can go ahead and notice that it says that this is a data frame of 209 observation with 12 variables. These 12 variables are given to you. तो अगर आप देखोगे ना बेटा, already he has gone ahead and given you salary of CEOs and उनका log of salary भी already given है आपको. So you don't have to convert the variable salary into log. Log form is already given to you. Similarly, if you notice in this data set, sales is given to you, but also log of sales is already given to you. And you are also given the return on equity and the return on stock. So if you go back to the question that we wanted to answer, we wanted to regress salary on log of sales. एक part था जिसमें we wanted to regress salary on log of sales. तो this log of sales वाला variable is already given to us. तो सिर्फ इस पे regress कर देंगे. And similarly, in one of the question, we had to go ahead and we had to regress log of salary on sale. तो ये log of salary variable को y variable मान के we will go ahead and regress that on sales and ROE. So the question is pretty simple that we are trying to go ahead and answer in this activity. ठीक है बच्चे, before we go ahead, this is my data set. I am just trying to show you this data set. So the entire question wants us to work on salary. We will be working on the return on equity. We will be taking the variable log of salary. We will be taking the variable log of sales, and we will be taking the variable sales. So these are the columns that we are interested in. Baki columns kisi kaam ka nahi hai. We are only going to go ahead and use these columns, right? As you can also see कि ये वाले जो columns हैं, these just take the values zeros and ones. तो ये सारा dummy variables हैं, but we have already learned how to work with dummy variable in the last class. In today's class, we are only going to talk about functional forms. Okay, beta. So I am going to go to the first case in which I will run a linear regression model, the most basic model, linear regression model. Let's see how we will go about it. So these steps are pretty simple. बेटा कुछ नहीं कर रहे हैं, कुछ packages को install और load कर रहे हैं. I already explained you in last class also. Let us try to understand this thing. So try to see that beta I explained you using the example of an app. तो whenever you install any app on your phone, install करने से app खुद से नहीं खुल जाता. It does not open on itself. You need to also go ahead and open the app. Click on opening the app. Only then the app will open and you can use the app. The same is the case with packages. You need to first install the package in R environment, but just installing the package is not enough. You need to also make sure that you have loaded those packages. जो भी आप package install कर रहे हो, you need to make sure that you have also gone ahead and loaded those package, right? So this step is going ahead and installing and loading the packages. So I'm going to just run this document till this much. It is saying you want the package to be updated. Yes, please go ahead and do that. Do you want to restart R prior to install? Yes, please restart it. So it will just go ahead and restart R. The entire environment will be restarted. There is a new global environment. You see this buffering going on. It just means that you're working with a new global environment. Everything has been cleaned and you're working with a new environment. Okay. Now what I am going ahead and doing, I am just going ahead and reading the CSV file. कौन सा file है बच्चे? The file name is CEOSAL. And you need to also understand कि जब हम इस file को पढ़ते हैं, the command we use is called read.csv. और बेटा I am just installing this file or using this file from this address. ठीक है, तो if I just go to my downloads folder, वहां पे इस address के साथ ये file था, तो I have just copied the address of the file as it is, right? Remember that whenever you will use any particular file, तो जब आप किसी भी file का properties पढ़ते हो, it comes with backslashes. You need to convert them into forward slashes. Only then its address will be useful. ठीक है जी? So what I am doing, I am reading this file and I am naming this file as CEOSAL1. That's it. So this step is very, very simple. I am running this command. ये कमांड सिर्फ फाइल को पिकअप कर रहा है. कहां पे है ये फाइल? This file is present in this folder. It is just reading this file और उस फाइल को I am storing as a variable here. और इस फाइल का क्या नाम दे रहे हैं बच्चे हम? We are naming it as CEOSAL1. So if you look into the right hand side, आपको यहाँ पर एक data set दिखेगा. You will be able to see a data set that has been created. And if I just open this, all these variables will be coming here, beta. Salary, sales, rate of equity. हाँ, ये सारा का सारा variables you will be able to go ahead and see on the right hand side. Am I clear with this? Okay. Now I will go to my first question, beta. So in the first question, I have to go ahead and I have to run a linear model. So if I just go back to the file, linear model means I am running salary. ठीक है, सैलरी इज माई डिपेंडेंट वेरिएबल और मैं बोल रही हूँ सैलरी दो चीजों पे डिपेंड करेगा. सैलरी विल डिपेंड ऑन टू थिंग्स. नंबर वन, सैलरी विल डिपेंड ऑन द सेल्स. जितना ज्यादा कंपनी का सेल होगा, द सीईओ विल गेट मोर सैलरी. सो सैलरी विल डिपेंड ऑन सेल एंड सैलरी विल डिपेंड ऑन द रेट ऑफ इक्विटी. So my first model, I am running salary as a dependent variable and I am taking two independent variables, beta, sale and rate of equity. तो देखो यहाँ पर जरा जाके, this is what I have gone ahead and I have done in this first model. I am saying make a model. इस मॉडल का हमने नाम दिया है. The name of the model is model underscore linear. This is the name. और इसमें what are we doing? We are running a linear model. So the word LM means that run a linear model. And beta, what is my dependent variable? Salary. And what are my independent variable? ROE and sales. So I have two independent variables, ROE and sales. And I have one dependent variable, that is salary. And beta, क्या है मेरा data set? My data set is CEOSAL1. So this is my data set. Am I clear with this? इसमें there should be no doubt at all. हम एक मॉडल रन कर रहे हैं. The model is a linear model. In this model, I have a dependent variable. Dependent variable is salary. I have two independent variable, ROE and sales. The data set that I'm working on is CEOSAL1. And the name I am giving to this model, उस model को हमने जो नाम दिया है, that is model underscore linear. So the moment I will run this model beta, you will see कि right hand side पे एक model create हो गया है. So run this. Notice that a model has been created on the right hand side. And इस model के अंदर it is telling me about the coefficient, about the residuals, about the fitted values, etc. etc. ये सारा चीजें इस model के अंदर आ गया है. All these things have come inside the model. What you can go ahead and do is you can see the summary of this model. तो अगर मैं summary को run करूंगी, I will be able to go ahead and see a summarized version of this model. देखो, I am able to find the residuals, the coefficients, the significance, everything is coming in the summary of this model. But I can go ahead and get this summary in the Word document. So I will just do that, but I can also just find out the R square value of this model. So यहाँ पे देखो मैंने लिखा summary में से क्या निकाल के दो मुझे R square का value निकाल के दो. So if I will run this beta, तो I will get the R square value. तो R square का value आ गया 0.029 और उसी summary में से I can find out the adjusted R square beta. तो if I run this, मुझे adjusted R square मिल जाएगा. Because these were two separate tasks that had to be performed within this regression. There was a question which said find R square, find adjusted R square. So although R square and adjusted R square summary में दिख रहे हैं, as you can see here, this is your R square and this is your adjusted R square. Still, अगर आपको उनको अलग से निकालना है, you can just use dollar. And उसके बाद I want to find out R square, so I have written R dot squared. And then dollar के बाद adjusted R dot square. And this will help me to get R square and adjusted R square separately in the model. अच्छा, now if I want to get this in a document file, तो मैं क्या करूंगी ना, I will just go ahead and run this command. तो इसमें I am saying स्टार गेजर बच्चे मुझे हेल्प करता है कि मैं एक HTML या वर्ड फाइल में अपने डेटा को कलेक्ट कर पाऊं. एंड किसका मेरे को डेटा चाहिए बच्चे? आई नीड द रिजल्ट ऑफ मॉडल अंडरस्कोर लीनियर. सो आई नीड द रिजल्ट ऑफ मॉडल अंडरस्कोर लीनियर, राइट? माई टाइप विल बी HTML एंड माई आउटपुट विल बी इन द फॉर्म ऑफ अ डॉक्यूमेंट फाइल. और इस डॉक्यूमेंट फाइल को आई एम गिविंग द नेम reg table 1. So the moment I will run this now, I will get a document file. I'm just running this command. Oh, it says could not find Stargazer. Why? We have already loaded the package Stargazer. Okay, now let me just go ahead and rerun this. Yeah, it's here. Okay, so sometimes what happens now, if you don't load the library property, it may give you some error कि I could not find this document, I could not find this library. जैसे यहाँ पे उसने बोला ना, see it says error, could not find the function Stargazer. So the reason would be that you could not load the library properly. So go ahead and reload the library once and then run this command, it will work properly. Okay. So what I can go ahead and do therefore beta, I will say reg table 1 and I will just open this file that has been created. So just see here that this data, जो भी हमारा result आया है from the first regression model, I have got this data here. अच्छा, just notice here that this gives you R square, this gives you adjusted R square, and this also gives you कि कौन से p value पे it is significant, right? It tells you that this is significant at 10% or 5% or 1%. किस पे significant है वो भी ये बता रहा है, right? So this is also something that we now know. Now I will just go ahead and make a note of this information in my tab so that we can interpret this. तो हमें क्या मिला बच्चे? What is the information we have got? We have got salary is equal to, what is the constant we have got? 830.631. 830.631. And then we have got ROE. So ROE ka coefficient is 19.631 ROE. And then we have got the coefficient of sales. So 0.016 sales. This is the model we have created. And then we have got that R square is given to us as 0.029 and our adjusted R square is given to us as 0.020. Okay, now let me just take you to the tab and let us try to interpret these results. Okay, so in these results, we go ahead and we notice that first of all, these betas, they are only significant when you have your 10% level of significance. हाँ, तो ये बस ये बताता है that you will be able to justify their significance using hypothesis testing for 10% level of significance क्योंकि single star था. Now let us try to go ahead and let us try to interpret what these betas mean. So this is model number 1 beta. And I am saying that as my ROE increases by 1 unit, that means the return on equity increases by 1 unit, then on an average, my salary increases by 19.631 units, right? There is a positive relationship between return on equity and salary. Similarly, if I just look with sales, so I am saying that as sales increase by 1 unit, then on an average, salary increases by 0.016 units, right? बेटा एडजस्ट ये R square है 29%, तो we can say that 29% of variation in salary can be explained due to variation in ROE and sales together. Right? And adjusted R square is 0.20. So adjusted R square just considers कि you have considered the degree of freedom. So considering the degree of freedom, 20% of variation can be explained. Taking degree of freedom into account, 20% of variation can be explained. So this is your first part, beta, कि obtain the regression results and export in a document using Stargazer. And we have also interpreted the regression coefficients and the R square and adjusted R square also. Now let me go to the second part. So second part में बोल रहा है salary as a function of ROE and log sales. Okay. So if I just go back to my file now again. So now I am not looking into this beta. ये वाले हमें चीज का जरूरत नहीं है. And rather I need to look into log sales. So we are saying that we want salary as a function of not log salary. तो अब जो हम मॉडल रन करेंगे, we want salary as a function of ROE and as a function of log sales. ये तीन चीजें हमारे पास रहेंगी, right? So what I will go ahead and do now, let me go to R again. This is called as a linear log model. Why is it called as linear log model, beta? Because I see that salary is coming linearly, ठीक है, बट सेल्स इज कमिंग विद लॉग. तो मैंने सेल्स वाला कौन सा फिगर लिया है? आई हैव टेकन दिस लास्ट कॉलम विच सेज लॉग ऑफ सेल्स. दैट मीन्स ये वाला जो कॉलम है ना बच्चे, दिस कॉलम, आई हैव टेकन लॉग ऑफ दिस कॉलम एंड गॉट दिस कॉलम, है ना? जब हम इसका लॉग लेंगे तो आई जस्ट कैन प्रूव दिस. सो इफ आई जस्ट गो ahead and say ln natural log of this sales sales and I just run this, I will get this value. देख रहे हो? So when I go ahead and take log of this, I will get this. Right? So this is just going ahead and saying कि log sales hai. This has been the log of these sales. So now I need to run regression of the salary with ROE and this log variable, right? So this is what I have gone ahead and I have done here. So I am saying now take another model, name this model as model linear log. ठीक है? And run a linear regression. And in this regression हम क्या कर रहे हैं? We are running salary and salary is being run on ROE and it is being run on log of sales and data set is CEOSAL1. Again, beta, I am generating summary of that regression और फिर इसमें से summary में से I can go ahead and I can specifically find out R square का value. I can find out adjusted R square का value and I can also go ahead and I can bring that model in the doc, right? और यहाँ पे ना I've just changed the name of the doc file and I have just named the doc file as regtable2. ठीक है? So now what I am doing, I'm going to run this command beta. So first I will run this. When I run this, देखो यहाँ पे linear model one log has been created. Again, this has the same things, coefficient, residual, ये सब कुछ दिखा रहा है. Then you can go ahead and generate summary of model linear log. So I'm just generating a summary. This is the summary of this model. Then I am finding out specifically the R value, R square value. Then I am going ahead and I am finding out the summary of adjusted R square. And then I'm going ahead and I am just putting them in a table in the doc file. Right? So if I just now open this reg table 2, this is the last reg table 2 file. Right, let me just open it again. So you will get these results in the doc file now. देखो ध्यान से बच्चे, this is salary. Salary के साथ it's regressed on a constant. Of course, you will have a constant. And then you have this ROE, which has become more significant now because it is significant even at 5%. Do star hai. So it is significant even at 5%. And the log of sale is significant even at 1%. So 1% tak pe bhi it is significant. That means it is highly significant. ठीक है? You will be able to reject null in favor of alternative. Acha, now your R square has also tremendously increased. So your R square is now 0.057. वहां पे 0.029 था. Oh, I just made an error beta. It was 0.029. So if I multiply it with 100, it would mean that 2.9% of variation, not 29. It will be 2.9. I will just correct this percent of variation. So your R square has increased now and your adjusted R square has also increased. So clearly this is a better model to go ahead and work with. अच्छा, एक चीज और यहाँ पे हम देख सकते हैं that your F statistic value is highly significant. So which means that they are jointly also significant, right? These two variables jointly also are significant. Jointly, they explain the variation in salary. Let me go ahead and write down this model beta. So I'm just taking this information to my tab now. So I have got salary is equal to constant minus 1482.29 plus 22.67 ROE plus 286.25 LN sale log of sales plus UI. This will be your model beta. ठीक है जी? And you can clearly go ahead and you can notice that your R square is coming out as 0.057 and your adjusted R square is coming out as 0.048. ठीक है? And F value is highly significant because it is significant at 1%. So which means that they are jointly significant. Now let me go ahead, take you to my tab, and quickly let's try to interpret these results. Every time you run a model on R, you have to make sure कि आप उन results को भी interpret करो. Only then it will make more sense. ठीक है? Just writing this down in a Word file will mean nothing. You need to make sure that you also interpret these results, right? So I'm just going to share my tab screen. Okay. So in the meanwhile, what we can, in the meanwhile, while we generate these results, what we can go ahead and what we can do is we can also generate the results of the third model. So try to see here, beta, I am running a log model in this case, right? And when we go ahead and when we run a log model, what happens in this case, beta? So now my variable that I am taking, a log linear model, the variable I am taking is log salary, right? And on the right hand side, I have both of them in the linear format. So if you just go to your Excel file, dekho yahan se, now what I am doing is I don't need salary variable anymore. So what I have taken is I have taken the variable log salary. This is the variable I'm working with. And I am regressing log salary on my ROE and on sales. तो अब right hand side जो है वो पूरा linear है, right? Right hand side is completely linear. And the left hand side that I am talking about, wo log form mein, right? So this is what we are doing in the third model. So try to see here, this is my log salary beta. And I am trying to run log salary on the ROE and on my sales. So these two variables have become linear and this has become in the log format. And the data set remains the same, CEOSAL1. And then I am just going ahead and generating a summary of this model. Then from that summary, मैं R square का value निकाल रही हूँ. From the same summary, we are finding out adjusted R square. And then we are just going ahead and getting that in the document folder. So let us try to run this beta. First of all, I am going ahead and generating my log linear model. So I have just generated a log linear model. The moment I run this command, dekho, I will again get all these values, coefficient, residual, rank, fitted values, etc. Then I am going ahead and I am getting a summary of this model. So the moment I run this command of summary, you will notice that here this entire summary has been generated. ये देखो ये पूरा summary यहाँ पे आ गया है. I have got this summary of the model. And now we can go ahead and we can, from this summary, देखो, summary में I am already getting the value of R square and adjusted R square, right? But now what I want is if from the summary I want to pick up the value of R square, so I can run this command separately and I can say कि इस summary में से मुझे R square का value दो. So what I have done is I have just written this summary as it is. And then I have used this dollar sign. And then I am saying now give me the value of R square. So I am just running this and it gives me R square. Similarly, from this summary, I can find out the value of adjusted R square. That means considering the degrees of freedom. And when I will just go ahead and run this command, it will give me the value of adjusted R square. Adjusted R square takes degrees of freedom into account. और उसके बाद हम एक बस डॉक्यूमेंट फोल्डर में इस पूरे को एक्सपोर्ट करेंगे डेटा, दिस रिजल्ट. तो आई एम जस्ट रनिंग द कमांड स्टार गेजर एंड देन आई एम रनिंग ऑन मॉडल लॉग लीनियर और यहाँ पे मेरा ये रेक्टेबल आ गया. सो आई विल जस्ट रन दिस कमांड, राइट? The moment I run this command, I will go ahead and I will have this data in the document folder. So let me just go ahead and open this rectable 3. And this is my rectable 3. अब rectable 3 में देखो, the salary is in the log format and बाकी सब कुछ linear में है. You see this? This is in linear. This is in linear format. और एक बात है that I want to focus on. देखो, if I just keep the two models side by side, let me just help you with the two models side by side. So this is rect table 2 beta, right? And this is rect table 3. So my question to you is that can we compare rect table 2 with rect table 3? The answer is no. Why? Because in your rect table 2, your dependent variable, that means your salary, the y variable, it is coming in the linear form, right? And in rect table 3, your dependent variable, that means salary, it is coming in the log form, right? And when your y variable, when your dependent variable does not come in the same format, एक में it is in the log form and एक में it is in the linear form, you cannot compare the R square of the two models. The R square of the two model is non-comparable. So I cannot go ahead and say कि यहाँ पे 12% of variation is being explained. In this model, 12% of variation is explained. And in this model, only 5% of variation is explained. तो दिस मॉडल इज बेटर. नो, ऐसा हम नहीं बोल सकते हैं. वी compare the two models because the dependent variable is not coming in the same format. In this, the dependent variable is in the log format, whereas in this, the dependent variable is in the linear format. So if the dependent variable does not come in the same format, the two models cannot be compared. आप उन दो मॉडल को कंपेयर नहीं कर सकते हो. You cannot compare the two models. Am I clear? So these two models are non-comparable. Right? अच्छा, एक चीज देखो, adjusted R square will always be less than R square. And the reason behind this is that adjusted R square takes into consideration the degrees of freedom, right? So whether I talk about this model or this model, adjusted R square will always be lower than R square. Am I clear with this fact? Okay. Now let me quickly take you through the last model. So this is my log model beta. In this, salary is also in the log format and sales is also in the log form, right? So I have gone ahead and taken salary also in the log form and sales also in the log form. So this is a log model. So I am naming this model as model underscore log underscore log. And then I am just asking to generate a summary of this model. उसी summary में से I am finding the value of R square, finding the value of adjusted R square, and finding this entire result in the doc format. So let's try to see this thing, beta. Here I have run this regression. Regression run हुआ है log salary का on ROE and log sales. I will just run this regression. After running this regression, you see that this model has been created, which is called model underscore log underscore log. अब I am just generating a summary of this regression model. ये इस model का summary है. Now I am just finding the R square value from this model. देखो R square 28% आया है. I am finding adjusted R square. Adjusted R square is approximately 27%. And I am going ahead and finding the entire data information, जो भी ये summary है, in the form of a doc folder. I'm just running this. And now I can just open this doc folder. So I will get rect table 4. Oh, I haven't got it yet. Let me just rerun this thing. This is your rect table 4. So you see here, this is also in the log form. And this is also in the log form. And remember, beta, we know that whenever my dependent and independent variable is in the log format, तो ये जो beta होता है, this beta is actually elasticity, right? This beta is elasticity. So this 0.275 is actually telling us the elasticity between the salary and sales. So it tells us the percentage change in salary when there is percentage change in sales, right? Again, this is giving you R square and adjusted R square. So, and you notice that F value is highly significant, which means that these two variables are jointly impacting your dependent variable, right? So now we have been successfully able to run all the 4 regression beta. Let me see if I am able to finally do a complete analysis of these models. So I am just going to collect the information from the reg files beta, and we will try to write all that information down. Okay. So beta, now from reg table 1, this is my reg table 1 information. I am just collecting it from the word file जो हमने बनाया था. We have got salary, right? I have got my ROE and I have got my sale. और ROE का coefficient is 19.631 and sale का 0.016. So the model that we generated, it says that salary is equal to 19.631 ROE plus 0.016 sales. And the constant that we had got, that constant beta, constant, that was 830.631. 830.631. And you have got your R square as 0.029 and you have got your adjusted R square as 0.020. Whenever you will be interpreting your R square or adjusted R square, just multiply it with 100. So R square is 0.029 into 100. This will give you 2.9%. So we are saying 2.9% of variation in ROE, in salary, can be explained from ROE and sales, right? Can be explained using ROE and sales. Achha. Now what happens is beta, as long as my dependent variable is the same, मतलब जो मेरा दूसरा model था, the second model I have run, उसमें भी my dependent variable was salary only. ये variable salary ही था. My independent variable एक तो ROE था, so this was having the coefficient 22.674. But the other independent variable was in the log format. So this was log sales and this was 286.265. And then you had the constant as minus 1482. The first thing that you have to notice is that because the dependent variable is the same, it is in the same form, these two models are comparable. I can compare these two models R square. इनके R square को हम compare कर सकते हैं because the dependent variable is in the same form. So if I just go ahead and I just run this regression, what will I go ahead and get? I will get that RO. So I will go ahead and I will get my, salary is equal to, constant is minus 1482 plus 22.674 ROE plus 286 log sales plus UI. Acha, now we need to interpret this coefficient once beta, 286. So try to understand, if I just differentiate, क्या मिलेगा मुझे? D sales, D salary, how salary changes is equal to 286. But if I am differentiating, so this will give you 1 by sales, D sales, right? So in a way, if I just look on the right hand side, ये वाला जो form है, this is telling me the percentage change in sales, right? It is telling me the relative value of sales. और ये जो है हमारा, this is telling me the absolute change. right? And this is giving me the percentage change or the relative change rather, right? And this is 286. So if I were to interpret this 286 coefficient, so I can say that this 286 tells me what will be the absolute change in salary due to the relative change in sales. So it is telling me the absolute change in salary. Salary में absolute change कितना आ रहा है due to the relative change in sales. Sales का relative change देख रहे हैं because I have this in the log format. ठीक है, this is a very important implication. अच्छा, बाकी things are same that if I have to interpret R square, so R square in this model is given as 0.057. So 5.7% of variation in your salary can be explained due to variation in log sales and ROE. Or adjusted R square takes into consideration degrees of freedom. Now let me go ahead and go through the third model that we had run beta. So the third model tha, it was reg table 3, and in your reg table 3 actually, your model that you were talking about, it was actually log salary, right? And then you had ROE, and then you had sales, and then you had constant, right? And your ROE was 0.015, right? And just 1 minute. Okay. So then your ROE was 0.015. Your sales was 0.00002. And your constant was 6585. This was your constant, right? There is a point here. So now let me just try to go ahead and explain this beta. So we are saying that log salary is equal to 6.585 plus 0.015 ROE plus this so small coefficient 0.00002 sales plus UI. अब अगर I need to interpret this coefficient beta, so what will be the implication of this coefficient? So this is going to be, so if I just differentiate, I will get 1 by salary, D salary is equal to 0.00002 D sales, right? So this is telling me the relative change in salary due to the absolute change in sales, that will be 0.00002. Relative change due to the absolute change. Acha, one more thing that you have to understand. Whatever is its R square, so its R square value is actually coming out as 0.129. That means 12.9% of the variation in log salary can be explained jointly by ROE and sales. So ROE and sales jointly can explain 12.9% of variation in your log salary. अच्छा, because here your dependent variable is log salary, और इससे पहले वाले models में the dependent variable was salary. These models are not directly comparable. Because the dependent variable has changed, I cannot go ahead and directly compare these models, right? At last, beta, you had model number 4. I'm just going to write down the results of model number 4. So model number 4 that I had, that was basically, the results of model 4 are basically log salary, right? And here you had ROE, and here you had log sales, and this was 0.275, this was 0.018, and this was a constant, and the value of constant was 4.362. So what you can now do now, you can write log salary is equal to 4.362 plus 0.018 ROE plus 0.275 log sales plus UI. So try to see now that this is actually beta. This is actually a elasticity. Why? Because I have log here and log here. So this is actually telling me what is the percentage change in salary due to the percentage change in sales beta. And that is 0.275. And its R square is coming out as 0.282. So we can say that 28.2% of variation in log salary can be jointly explained through ROE and log sales, right? Acha, now just see that here, beta, my dependent variable is log salary. And here also my dependent variable is log salary. So these two models within themselves are comparable. In दो models को हम compare कर सकते हैं. Comparable. But this is not comparable with the previous model where my dependent variable was salary. Am I clear with this? Okay, so with this beta, we have tried to, I think, answer all the questions. We have gone ahead and we have discussed all four models. And this is a good way to understand the functional forms. So I will go ahead and end today's session with this. Thank you, beta.